Flow in. Welcome, everybody, to the April version of the Cleveland AWS User Group meetup. Glad you can make it or are watching on video. We are excited to have Piyushi here today talking about architecting governed healthcare data platforms on AWS. For some of you, it might be remedial, some it might be a stretch. Everyone's welcome here, so please ask questions in chat. If we've got a small group, we could probably come off a mute at some point. Piyushi, do you prefer that people raise their hand and ask questions as we go? Or we can hold them to the end. What's better for you?
We can we can have everything together at the end. Yeah, that sounds better. I'm gonna be finishing I'm gonna have everybody have 20 minutes, 25, yeah.
Wonderful. All right. So you've got chat available to you. If you could just put your questions there, and then I will facilitate it at the end. So without further ado, I'm going to hand over the microphone.
Thank you so much, Kathy. Hello, everyone, and thank you so much for attending the session today and giving me this opportunity to present in front of this audience. I'm gonna apologize in advance because I have a little bit of cold and cough situation. So in case you see me coughing, I apologize. Today's topic that I'm gonna be presenting and talking about is about architecting governed healthcare data platforms on AWS. For those who may not be familiar, AWS stands for Amazon Web Services. It is a cloud computing platform from Amazon that lets you use technology services over the internet instead of owning physical servers. With AWS, you can store data, run applications, and process information on demand. And you only pay for what you use. It helps so many companies scale quickly, stay secure, and avoid managing their own hardware. With that, I would like to introduce myself. My name is Piyushi Sharma, and I'm presently working for IQVIA. I'm a customer success support manager with IQVIA. I've successfully completed over 4 years and 7 months with IQVIA, and overall, I carry over 17 years of work experience across healthcare and banking domain. I currently lead the patient and practitioner operations within IQVIA, and I hold a Master of Science in Business Analytics, Business Intelligence and Analytics from St. Joseph's University from Philadelphia. Um, there is a lot of work that I do. I just try to cut it short into something, and you can ask me anything about it, so maybe we can keep it for later. From this session, so here's the slide which tells you about what the audience is going to gain from today's session. I will talk about how to design AWS architectures with governance built in from day one to enforce ownership, access control, and ethical data use. Practical, repeatable patterns to meet HIPAA and GDPR using RBAC, which is your role-based access control, encryptions, and audit trails. HIPAA and GDPR using RBAC means meeting data privacy and security rules by controlling access through roles. Ways to collaborate across institutions using federated AWS architectures without losing data ownership. Analytics approaches on AWS that extract value while protecting sensitive data by design. Here is a breakdown for those who are unfamiliar with this terminology. I'm sure everybody is, but just in case, I like to do that. HIPAA stands for Health Insurance Portability and Accountability Act of 1996. It is a US law that protects patient health information. It requires strict limits on who accesses medical data and why. GDPR stands for General Data Protection Regulation. It is a European law that protects personal data. It requires access controls, data minimization, and accountability. RBAC is a role-based access control. a security method where users get access based on their job role, not on the individual permissions. On this slide, we are going to talk about healthcare organizations moving from on-premise systems to cloud-based real-world evidence platforms. This shift supports scale, speed, and collaboration. What real-world evidence means here? It refers to data from real clinical practice, example EHR, electronic health record data, claims, registries, observational data sets. This data supports research beyond controlled clinical data or clinical trials. Cloud platforms scale for growing data volumes, multi-institution research, elastic AI workloads, and faster insight timelines. They enable large-scale clinical research, population health analysis, AI-driven insights, and secure cross-institution collaboration. This shift has raised new governance, compliance, privacy, and architectural demands, which the session addresses through practical design patterns. Now, this slide explains why governance becomes harder as healthcare data moves to the cloud. Cloud scale increases speed and access, but also multiplies risk. Manual policies do not scale. Governance must be built directly into the platform. As data flows across systems and organizations, privacy, access, control, and compliance must operate continuously and automatically. Multiple parties and overlapping regulations, such as HIPAA and GDPR, require strong isolation, shared responsibility, and enforcement by design. The key takeaway from this slide is simple. If governance is not embedded in architecture, security, and data movement from day one, it will fail at scale. Ethical data stewardship as architecture. Like the slide says, this explains that ethical data stewardship is enforced through system design and policies or checklists. Consent. Consent, accountability, and responsible use are built directly into the platform using fine-grained access controls, immutable audit logs, and purpose-based permissions. The core message is simple. Ethics are enforced by architecture. The platform itself ensures data is used correctly, traceably, and only for approved purposes. Translating ethics into AWS controls. Now, this slide summarizes how ethical principles are enforced through AWS platform controls instead of policies. So ethical intent is translated into technical enforcement using native AWS services. Consent is enforced at query level, or query time through AWS Lake Formation using fine-grained data permissions. Accountability. Accountability is enforced through CloudTrail logging and Macie-driven sensitive data discovery. Responsible use is logged in via services control policies and IAM permission boundaries. The core message is simple on this slide. Ethics become operational only when governance is embedded into the platform architecture itself. For those who are not familiar with the terminology, simple form, the lake formation controls who can access data and how they can query it. Macie identifies where sensitive data, sensitive information exists, and alerts on privacy or exposure risk. Together, they support governed access, privacy protection, and audit readiness within AWS model. secure RWE platform architecture on AWS. This slide summarizes a secure RWE platform architecture on AWS. Access is controlled at the core using IAM, Cognito, and private network endpoints. Data is governed at ingestion level using S3, Glue, Lake Formation, Macy, and CloudTrails. You have a number of tools that you can actually use. Analytics run on Athena, Redshift, and SageMaker within enforced security and compliance controls. For those who are not familiar with the terminology, IAM stands for Identity and Access Management. And if a question comes to you, do I need all of these tools? The short answer would be no, you do not need all of them. You need a small, deliberate set. The rest are optional based on risk, scale, and regulatory pressure. The key takeaway on this slide would be security and privacy and compliance are embedded at every layer, each layer, not added later. Data ingestion layer, building the foundation. Now, building the foundation here means this is the first and most critical stage of the platform. Decisions made here determine data quality, trust, and compliance downstream. Healthcare data enters the platform through multiple controlled pathways. From the first step, the architecture ensures integrity, traceability, and regulatory compliance. Real-time streaming. So what exactly does real-time streaming mean? This path is used for live data such as EHR feeds and clinical events. Amazon Kinesis ingest data continuously as it gets generated. This supports near real-time insights, monitoring, and rapid response. Controls at this stage ensure that data is captured securely and without any loss. Batch processing. This path is used for historical claims data and large legacy data set. AWS Glue processes data in batches and transforms it into analytics ready formats. This ensures consistency, standardization, and quality before data is used for analysis. Direct S3 upload. Now, this path supports secure self-service uploads for research data sets and ad hoc contributions. Amazon S3 provides control storage with versioning and compliance features. This allows teams to contribute data safely without bypassing governance. The key takeaway from this slide would be the ingestion layer is designed to handle different data types and speeds up the process without compromising on security or compliance. Every pathway is governed from the start. This ensures trust or trusted high quality data flows into the RWE platform and supports downstream analytics with confidence. AWS Glue. Now, AWS Glue is the ETL backbone for healthcare data. It handles extract, transform, and load activities without any servers. It supports large-scale healthcare data sets while maintaining governance and compliance. Glue discovers raw data in S3, captures schemas, and centralizes metadata in the data catalog. Serverless ETL jobs transform and standardize data while maintaining compliance. Curated data is reliably loaded into analytics systems with full auditability. This slide shows that AWS Glue is not only a data processing tool, but it is the backbone that connects ingestion, governance, and analytics. It ensures healthcare data moves from raw to trusted in a controlled, scalable, and compliant manner. The overall message on the slide, though you'll feel that we are doing a lot of repeat telecasts, but the overall message on this slide is Amazon Lake Formation simplifies how data lakes are built and governed. It centralizes security and governance, so access, sharing, and compliance are enforced consistently across all data sets. Centralized permissions replace complex S3 policies with a single control model. Fine-grained row and column-based security protects PHI and PII. Secure cross-account data sharing enables collaboration without any need to copy the data. Tag-based controls support scalable governance across growing data sets. Native integration with Glue, Athena, or Redshift ensures governance is continuously enforced. Overall, the slide shows that Amazon Lake Formation acts as a governance layer for the data lake. It centralizes permissions, enforces fine-grained security, and enables safe data sharing and scales governance across the analytics ecosystem. Governance is enforced by the platform, not dependent on manual processes. Real-world evidence from data to insights. Now, real-world evidence uses data from everyday clinical practice to improve care, to speed up the drug development, and to enhance patient safety. The value comes from following a disciplined process, not from raw data alone. The first step in this process is collect. Now, this step focuses on gathering data from multiple real-world sources. These could include EHRs, insurance claims, registries, and wearable devices. All data is ingested into a secure and compliant data lake to ensure privacy, integrity, and regulatory alignment from the start. The second step in the process is harmonize. Once data is collected, it is standardized and linked. Disparate data sets are cleaned, masked, or de-identified, and reconciled to resolve any inconsistencies. This step ensures data quality and it creates a unified view that is suitable for analysis. The third step in the process is analyze. Advanced analytics are applied to the harmonized data. This includes statistical methods, machine learning, and pattern analysis. The goal is to identify trends, relationships, and outcomes that are not visible in the isolated data set. The next step in the process is to validate. Now you have collected the data, you have harmonized the data, you have cleaned the data, de-identified the data, you have masked the data, you have done your QC checks on the data. That is called validation. What is the next step? I just said. So validation is findings, all the findings are rigorously tested before being used for decision making. Validation includes robust methodologies, peer reviews, and clinical, even acquiring clinical expertise. This ensures insights are reliable, reproducible, and suitable for regulatory or clinical use. The overall message on this slide is RWE is a disciplined process. Data moves from collection to harmonization, analysis, and validation. Each step builds trust and credibility, ensuring insights are both actionable and scientifically sound. Amazon SageMaker for clinical ML models. This slide explains how Amazon SageMaker is used to build, deploy, and govern machine learning models for clinical use. Clinical predictive models. The clinical predictive models, for example, SageMaker, is used to develop and train predictive models using diverse clinical data sets. These models support use cases such as disease diagnosis, treatment response predictions, and patient risk stratification. The focus is on producing accurate, clinically meaningful predictions that can inform care and research decisions. De-identified training. Model training is performed on de-identified patient cohorts. This protects sensitive patient health information while still allowing robust model development. Secure environments ensure data privacy is maintained throughout the training process. Bias detection, if there is any. So bias detection with Clarify. SageMaker Clarify is used to detect and measure bias in clinical models. It evaluates whether predictions differ unfairly across patients or patient demographics. This helps teams identify and mitigate any bias, supporting fair and equitable outcomes across population. The last one is the production monitoring. Once models are deployed, SageMaker supports continuous monitoring. It tracks data drift and model performance over time as real world data changes, or this also ensures models remain accurate, reliable, and clinically safe in production environments. The slide shows that SageMaker is not only a model development platform, it is a governed machine learning lifecycle for healthcare. It supports predictive modeling, privacy protection, fairness checks, and ongoing monitoring, making clinical machine learning trustworthy and production ready for all real-world evidence platforms. Incident responses and breach management. Now, this slide explains how incident response and breach management are designed on AWS as structured, automated lifecycle rather than an ad hoc reaction. It detects threats early in the process using Security Hub and Guard Duty with with the help of real-time alerts. It contains incidents automatically using Lambda, Event Bridge, and Systems Manager to limit the impact. It also investigates using CloudTrail logs analyzed in Athena to determine cause and scope. It remediates by patching, reconfiguring, and restoring systems through automated playbooks. Overall, the slide shows that incident response on AWS is automated, it's auditable, and repeatable. Detection, containment, and investigation, even remediation, are built into the platform itself. This reduces response time, it limits risk, and it supports compliance in regulated environments. Cost optimization without compromising on compliance. Now, cost optimization is treated as an architectural design. It's not treated as a cost-cutting service or a cost-cutting exercise, sorry. Savings are achieved using AWS native features that do not bypass governance, auditability, or data protection controls. Intelligent tiering lowers storage costs automatically without impacting security or compliance. Spot instances reduces cost for interruptible, non-regulated workloads. Reserved capacity optimizes spend for predictable, long-running analytics. Cost tagging enables chargebacks, transparency, and accountability across teams. Organizational complexity makes consistent tagging and governance enforcement difficult. Spot instances see limited use due to PHI handling and latency sensitivity. Reserved capacity carries risk when demand forecasting is uncertain, and data residency and retention rules restrict storage tiering flexibility. Strong compliance controls add operational overhead and slow optimization efforts. The bottom line would be this overall approach works very well, but corporates must balance savings with governance maturity. And not only governance maturity, but also workload predictability and regulatory constraints. Cost optimization is most effective when paired with strong operating discipline and executive alignment. FHIR on AWS. FHIR stands for Fast Interoperability, Fast Healthcare Interoperability Resources. So healthcare data lives in many systems. Interoperability improves when all systems speak the same language. FHIR provides that language. AWS provides the infrastructure to run it securely at scale. AWS Healthcare Store, AWS Health Lake stores clinical data natively in FHIR, reducing transformations and simplifying governance. FHIR R4 enables consistent standards based on data exchange across systems and organization. Data from EHRs like Epic and Cerner is normalized into a single FHIR model to speed analytics and application development. Amazon Comprehend medical turns unstructured clinical notes into structured, searchable data aligned with FHIR. Overall, the slide shows how FHIR on AWS turns fragmented clinical data into unified standards a unified standard-based platform. Interoperability improves compliance, it becomes easier, and clinical insights become more accessible. Disaster recovery and business continuity. Now, as the name of the slide itself says, this slide highlights how the platform keeps healthcare systems running during failures or disasters. Multi-region AWS architectures enables fast recovery with minimal downtime and near zero data loss. Patient data is protected through cross-region replications, multi-AZ deployments, and snapshots. Centralized backups and regular DR testing ensures predictable, compliant recovery during any incident that happens. Now, this slide, it explains how governance is built into daily data operations, not handled later at a separate process. Governance shifts left by embedding security and compliance checks directly into CI/CD pipelines. Infrastructure as code enforces consistent, auditable, compliant environments across all stages. Automation or automated compliance and data quality monitoring continuously protects accuracy, integrity, and regulatory alignment of all the healthcare data. Now, here's a case study. Let's discuss a case study and scalable real-world evidence for oncology. I just picked it up because I thought that it's going to be useful. Maybe you're already aware and you've already seen it. A research institution unified fragmented EHR data from multiple cancer centers into governed AWS data platform, everything at one place. Data preparation and cohort identification time dropped significantly. This is one of their observations, and accelerating oncology study timelines. Federated learning enabled cross-functional institution analysis without sharing raw patient data among each other, like within their system. Automated cohorts and controls ensured HIPAA compliance while supporting large-scale personalized cancer research. So practically, in today's scenario, even to give like a scenario from what I do in a day-to-day process. So when we collect data on a quarterly basis, I'm not allowed to name the data set, but let's say I collected oncology data from multiple sources. And so the first step in the process, and we've already studied that, when the data reaches to my team, it is already formalized, it is already masked, it is de-identified, it is already clean for us to create analytics on that and work on the cohorts. 3 years ago, or maybe I should say 5 years ago, when I was working with Concert AI Patient Solutions, this process used to take a lot of time from acquisition of data to while we could reach the analytics, working on analytics on the same data sets. And today, the same time has reduced to almost, I would say, not nothing, but still it has minimized drastically. And it has not only helped our customers achieve their business goals and become successful, it has helped the internal healthcare and pharmaceutical teams to become successful. Now, road ahead. This slide outlines key trends shaping the future of healthcare data and analytics. Generative AI is being embedded into clinical workflows to support decision-making and automate documentation and personalize patient engagement. Synthetic data is gaining traction to enable model training and research without exposing protected health information. AI governance and explainability are becoming essential to ensure fairness, transparency, and accountability in clinical AI. Zero trust security models are replacing parameter-based defenses to protect healthcare data against modern cyber threats. This slide provides a quick way to assess whether a healthcare data platform is ready for governance at scale. Identify and access. Identify and access controls enforce least privilege, MFA, and guardrails across the data lake. Data protection is handled through encryption, private access, and continuous sensitive data discovery. Audit and compliance. This audit and compliant capabilities support continuous monitoring, centralized logging, and HIPAA readiness. Operational readiness. It ensures disaster discovery and incident response, data quality automation, and cost control. They are all in place. Role-based access control, RBAC. This slide explains how access to healthcare data is tightly controlled by role and purpose. Access follows the principle of least privilege, so users only see the data required for their job role. AWS Lake Formation enforces fine-grained row and column level security, including PHI controls. IAM roles map directly to use agreements, allowing access to be granted, updated, or revoked automatically. The key point is that governance is enforced at every data query level, not documented after the fact. End-to-end on AWS. So this slide explains how healthcare data is protected by encryption, de-identification, or you can call it masking, at every stage of AWS. Data at rest is encrypted using customer-managed KMS keys, isolating PHI, de-identified, and aggregated data. Data in transit is protected using TLS with private network access and strict policy enforcement. Data in use is secured through confidential computing, preventing access even by cloud operators. Auditability. This slide explains how a complete tamper-proof audit trail is enforced for healthcare data on AWS. All actions are logged at the API and data access level using CloudTrail and Lake Formation. Alerts and compliance visibility are provided through CloudWatch and Security Hub. User logs sorry, I think I moved one slide up. Sorry. Oh, sorry, I moved 2 slides up. Auditability. So all actions are logged at the API level, at the data access level, using CloudTrail and the data lake formation. Alerts and compliance visibility are provided through CloudTrail, CloudWatch, and Security Hub, and all the customer logs are stored immutably using S3 object lock to meet regulatory audit requirements. Data minimization as a design pattern. Data minimization isn't just a regulatory checkbox. It is a fundamental design principle. Every unnecessary copy of PHI is a liability. By reducing exposure at every stage of the pipeline, you shrink the attack surface, you narrow the compliance scope, and build a platform that's easier to audit. It's easier to secure, and it's easier to trust. Less data in the wrong place means less risk everywhere. HIPAA and GDPR compliance on AWS. This slide explains how regulatory compliance is enforced by architecture, not assumed by the cloud provider. HIPAA compliance requires encryption, strict role-based access, and immutable audit logs across all usage beyond simply signing a BAA. GDPR compliance requires data residency controls plus built-in right to access, delete, and consent tracking across distribution system. The key message is that compliance is a shared responsibility and must be operationalized in the platform design. Multi-institution collaboration without losing the control of data. This slide explains how institutions collaborate on healthcare research without giving up on data control. Each institution keeps full ownership, encryption keys, and access policies over their own data. No raw patient data is shared. Only insights, model outputs, or aggregated results are exchanged. Even federated architecture enables collaboration while preserving privacy, trust, and legal compliance. Federated multi-account AWS architecture. Now, this slide explains how federated AWS accounts enable collaboration while preserving data control. Each institution operates in isolated AWS accounts, maintaining full data ownership and sovereignty at their own level. Central guardrails are enforced through AWS organizations and service control policies. Only approved resources or results are shared. Raw patient data never leaves the source account. Preserving local data ownership. This slide explains how data ownership stays with each institution in a federated setup. Each institution controls its own encryption keys, IAM policies, and storage. No central access to raw data is allowed to anybody. Data use agreements are enforced automatically through platform permissions, not only by legal contracts. Network isolation ensures data never travels over the public internet between institutions. Privacy preserving analytics on AWS. This slide explains how population level analytics run without exposing patient data. AI models are trained locally where data lives. No raw data record ever leaves its source system. Insights are generated safely while privacy remains fully protected. The first pattern, the federated learning. Now, this slide explains how federated learning trains AI models without moving patient data. Model training stays inside each institution's AWS account where the data lives. Only encrypted model gradients are shared with a central aggregator, never patient records. Even if the central layer is compromised, no raw patient data is exposed. The second pattern, differential privacy. This slide explains how differential privacy protects individuals in analytics results. Statistical noise is added to query outputs to prevent identifying any individual. Privacy budgets control how much information each query exposes. And insights remain accurate at scale, while individual patient level data stays protected. The third pattern, secure multi-party computation. This slide explains how organizations run joint analytics without getting exposed to the raw data. Each party encrypts and contributes data into a secure computing environment. Computation runs without revealing any participants' underlying records. Only approved and aggregated results are revealed, never raw patient data or provider data. Balancing privacy, performance, and cost. So we learned something about privacy. We have been talking about performance. We have been talking about governance. We talked about the cost. This slide shows how to choose the right privacy technique based on risk, performance, and cost. Low risk use cases rely on standard role-based access for speed and lower cost. Medium risk scenarios, they use differential privacy or federated learning to limit data exposure. Highest risk use cases require secure MPC or clean rooms, trading performance and cost for maximum privacy protection. Now, AWS Services Reference Map. This slide explains how AWS services combine into a layered governance model for healthcare data. Governance is built as stacked layers covering identity, encryption, access control, and auditability. No single service is sufficient. Each layer reinforces the others to reduce or to minimize the risk. Ongoing reviews using the AWS well-architected healthcare lens keep governance effective as the platform evolves. The overall from this, what are you going to take home today? This slide, it summarizes the core principles for building scalable, compliant healthcare platforms. Build governance into the architecture using access controls, encryptions, and consent enforcement from the beginning. Use federated multi-account design to preserve institutional data ownership while enabling collaboration. Apply stronger privacy techniques only where risk justifies them. And automate governance operations using infrastructure as code and centralize control services at scale. Some of the terminology you may have seen repetitively, just gonna say it. So PHI stands for Protected Health Information. and PII stands for personally identifiable information. With this slide, I thank you all for joining today, and I really appreciate that you gave me an opportunity to present in front of the audience, and I open the floor for any questions or any discussions.
Thank you so much, Piyush. If anyone has any questions, we've got a small group here today. Give me a second and I will make it so everyone can unmute yourselves if need be. Otherwise, you are welcome to put your questions in the chat. But you should be able to unmute now. All right,
I love
Ash.
the silence.
That's
I,
always a good
I
thing.
was
You covered it comprehensively. Oh, we've got a nice comment here from Ash. No questions, but you did a great job demonstrating how a variety of AWS services would be used in the context of healthcare data governance. And I really appreciate it as someone who recently acquired oh, Ash, you got your cloud practitioner. Yay. But whose knowledge is atrophied a bit. So great job, Piyush. Thank you.
Thank you so much. Thank you.
Kieran asked if any resources will be shared. We will be publishing this. Piyush is giving this talk in the DC AWS office in about a month. After that, we'll be publishing this on YouTube. But it's up to you, Piyush, if you're comfortable sharing slides. Get
Yes.
those to Kim, and we can make sure you get those, Kieran.
Yes, I'll definitely share the slides. I tried to make it as simple as possible. I had an understanding that maybe the audience in the group is going to be already aware of the terminologies, but I still tried to put it all in
It's always
the
good. We've got
simple
people
way
that are,
possible. I'll share the
yeah.
slides. Yes.
Wonderful. Yeah. So Kieran, we won't have the link for about a month, but we will definitely put that in the meetup. We'll put it in the discussion board once that link is available. Yep, and Ash will definitely make sure you get the slides. Excellent. Any other questions? All right. Well, thank you so much, Piyush. We'll look forward to seeing you in about a month at the Skills Center at HQ2. Have a great
Yes.
day, everyone.
Thanks, everyone. Thank you so much. Bye-bye.